Hello, everybody. Happy Friday. It's sunny out. I'm in here anyway. But probably after this, I'll be going out and enjoying the sun. Some of you are up late. Going to give a couple minutes for people to trickle in. Hey, Carlos. It was clean and organized once. And then I took a picture of it. Yeah, I'm excited to poke around at Pixie as well. Yeah, Pixie is a new project, newly open sourced project from New Relic, and we'll be taking a look at that today. Yeah, Seattle has gotten a nice burst of weather here. Um, it's been sunny all week, so it uses OpenTelemetry. I wouldn't say it was based on OpenTelemetry, but we'll take a look in a moment. I bet we'll figure out why a new monitoring project too. Um, I've only looked at it a little bit, but I think there's some interesting stuff. So let's see. We're gonna switch over to the notes and do a little week in review to start with. Um, so for those of you who are new here or haven't done this before, these notes are at tgik.io/notes. Um, and I will see if I can put that in the chat. Yes. YouTube doesn't like links in there. So if you try to put in a link, it may get broken unless you break them up. So, yeah. Anything cloud native related happened last week? Yeah, KubeCon. So I pulled out one talk that was interesting to me, but if other people want to call out talks, the notes are open in HackMD. I didn't put any more there. Two other things I thought were interesting. There's a Release 121 webinar, which is going to be describing all the features in 121 from the folks who actually ran the release, and that's going on later this week. So if you're curious, or I guess next week, it's Friday. And there's a KEP for swap that I thought that some people might be interested in. Oh, somebody's got the video playlist in here. Oh, yes. So, the last time I looked, they hadn't gotten it all into YouTube yet. So, yeah, it looks like here is the link to all the YouTube content. We're not going to... Yeah, you know how it says turn off swap? Well, who knows? In a release or two, we might end up saying actually swap can be on. Swap, like paging out to disk. Thanks, Rory. Yeah, Kubelet will refuse to start up if swap is on because it turns out if you move random pages from memory to disk, your performance gets really unpredictable. And so at Google, swap has been off for years and years. and when Kubernetes started up, they did the same thing, but it looks like some workloads really benefit from swaps. So, oh, awesome. The Kubernetes podcast was here too. And so, yeah, I thought it was interesting that we're going to be getting swap on Kubernetes. And yeah, let's see what else. So yeah, KubeCon, there's the video list. This is an interesting project that I saw on Twitter, and Joe called out as well. So KCP is a prototype of Kubernetes without pods or nodes or any of the I want to run code. It's just an API server. For those of you who might want to be able to write Kubernetes-like APIs, but don't actually need to do pods or nodes. So you can see it has namespaces and service accounts and custom resource definitions. But doesn't know anything about pods. And the goal is to actually get this into upstream as a tool for people who are building APIs. Martin, can you stick that in the HackMD, the hacking into Kubernetes security? That seems pretty interesting. And then it looks like the CNCF TOC accepted a whole bunch of new projects, so I figured I'd call them all out. Antrea is a CNI that uses open, what is it? Uses some of the software-defined networking stuff. And I'm trying to remember, what is it called? Open vSwitch. So it uses packet level forwarding inside of the node rather than the some of the BGP or other custom routing protocols. So seemed kind of interesting. Chaos Blade is a chaos engineering toolkit. Lets you take apart your cluster in random ways and see if it still works. I don't know if they have they've got a demo here, but I'm not going to watch the whole thing now. I'm not going to make you all watch the whole thing now. So Fluid, yeah, Carlos, go ahead and add that one to the list. I'm sure people will appreciate sort of a highlights. So Fluid is a tool for managing large data sets to go along with like machine learning and AI. And so it gives you a bunch of CRDs for describing where your data is across different storage areas. I think Submariner got talked about 2 weeks ago or so, but it got accepted into the sandbox. Did I say incubating? Oops. These were all sandbox, not incubating. Somebody just thought that everything was really exciting. Okay. So Submariner lets you connect. Oh, it would be really nice if they had a picture here. It lets you connect multiple Kubernetes clusters together without needing to go through exit from the cluster and then ingress through like an ingress or a gateway somewhere else. And they can kind of pipeline stuff through that channel. Vineyard, I didn't look too deeply into this, but it's a mechanism for whether you're building on a single machine or on many machines, having sort of a distributed file system and efficiently copying things between your preprocessor and your next data stage pipeline. Oops. Someone else's. I will wait till that's done. I was just going to put everything under the video playlist heading, or take it out. And let's see, the last one was WASM Edge, which is not the sort of thing that's going to make for a flashy demo, but is a WebAssembly virtual machine so that you can easily use WebAssembly in a bunch of different environments. And so, yeah, they've got how to run it, but they don't show you how to run Doom on it, so I can't really show you anything exciting. And let's see. There's a couple of blog posts here. I saw the Oracle one and thought that was kind of interesting. Apparently people are running Oracle on Kubernetes, which... Or maybe this is using Kubernetes to manage Oracle? Oh no, Oracle supports databases running in containers, so yeah. Apparently you can use Kubernetes to manage your Oracle database. Yeah, and the last thing is a series of blog posts that Falco did. For those of you who aren't familiar with Falco, it's a Kubernetes security monitoring project. And they did sort of, here's how to do the same response engine. So when you see certain unexpected system calls, you can react to it and, for example, shut down the pod. And they did a series of blog posts in conjunction with different projects. So 3 serverless platforms and then Tecton as well. And so here is how to build a function and do it with kubeless. And here's how to do it with OpenFAS. And here's how to do it with Knative. And someone saw this and said, hey, I'm going to show you how you do it with Tecton. But yeah, so Falco has built a integration using cloud events. So instead of needing to tie in really hard with one of these particular systems, you can take those cloud events and run them anywhere. So I thought that was pretty cool. And let's see. Unless anyone else has billing every time your pod's auto scale. Yeah. Looks like there's nothing else on these, in the comments. So we're going to start looking at Pixie, which it looks like the commercial version is branded this way, and then they have an open source version that looks basically the same. But this one is technically the New Relic one, and this is where Pixie Labs is going to be. So let's see. So they have just do this and it'll all work. I think, well, there's a note that there's a self-hosted install script coming soon. So yeah, someone was asking why a new monitoring project. Let's do that one first. So I don't know how many people have used New Relic before, but they've been in this application monitoring space for a long time. And you can kind of see from this little thing over here, they've got an ability to sort of track all the calls between your different components and build you traces and sort of why things are slow. And And it looks like Pixie also has the ability to kind of have a script and, get data out of the database. And here is how it all works. So they've got modules on each node, and possibly also off node, and then a central control server that talks to a potentially hosted API. So they've got a bunch of different use cases here. But the thing that I thought was really interesting is in their docs. How Pixie works. So they have a couple different mechanisms here. I'm going to blow this up just a little bit. Here we go. So inside your cluster, you have these edge modules on each node. Lots of different systems sort of have that, but they hook in with eBPF so that they can get kernel level syscalls. And then they do a Kubernetes native collection or Kubernetes native system with this Vizier agent that collects all the data from the different Pixie edge nodes. And then they have an option to send things to their cloud or do a direct connection called data isolation mode. And so you can push things to the New Relic cloud if you want, or you can run it locally. And they talk through a little bit more here. I guess that they use the control cloud as a reverse proxy, but without any persistence. So it's really easy to keep all your data local and not have to pay things somewhere else. Yeah. And so they claim low overhead and maybe the ability to scale out. And so, yeah, this is a no instrumentation approach where it's not quite no instrumentation, but it's very low instrumentation at least. You do have to build with symbols, I was seeing somewhere, or only parts of it work. But it will track things like HTTP and DNS and a bunch of other protocols without needing you to go in and specifically build against libraries, which is different than OpenTelemetry or different than what you'd use for Prometheus. So you'd normally, with Prometheus, have to kind of build in an endpoint. And apparently they also can work with OpenSSL and GoTLS to give you the encrypted payloads. I don't know. I don't know if it does WebSocket. My guess is they may be able to read the HTTP part of WebSocket. The rest of WebSocket is... Yeah, Sysdig has an agent like this. Wavefront has an agent like this. Instana, I think, is like this. And so here's a bunch more stuff. But, FAQs. SSL, TLS traffic. Oh, we're back on the Pixie Lab site. That's okay. Doesn't currently ingest data from Prometheus, but would like to. And yeah, so install. We're going to use Minikube. I've already got a Minikube cluster set up. I feel like daemon sets made agents a lot less invasive. Back in 2000, when we didn't have containers, and you had to install the agent, you had to worry about the library dependencies of the agent as well as the library dependencies of your actual application. and when they collided, then you were really sad. Yeah, if this only sent data to the cloud, it would be less interesting. Although if you could run your own cloud for sending the data to, that seems like would also be pretty cool. So let's see, local Kubernetes. Actually, let's look at the requirements first. So it looks like they support any reasonable version of Kubernetes you might use. But they support the big three clouds and self-hosted with some caveats. And so we are going to be using a Minikube environment. It looks like they don't support Kind or Docker Desktop, which is interesting. I'm guessing that's because of the eBPF needs. And we've got an 8 gig machine. Oh, this is interesting. It only supports x86 64. No ARM. So. And only supports Linux. I'm guessing that's again for the eBPF. And they've tested these distros. Oh, that's exciting. We recommend that Linux headers be installed on a cluster's nodes. I wonder why. And then it looks like it sends outgoing HTTP requests to the service. We talked about that in the architecture. So skipping over quick start, because we want to wait. Install scheme. We wanted local Kubernetes. The navigation here is confusing me because they have a just go forward, but then it skips over some of this stuff. So let's see. We've created the cluster. Oh, and then we just follow the quick start guide. Okay. So let's see. Okay, why? Okay. I just didn't copy over. So I'll get my my Linux cube config set up in just a moment, and we'll look at the quick start guide. I don't know what they're using for their docs. One thing they don't have, as far as I can see, is a link for how to actually update the website, which is kind of nice. I noticed some other sites are having, where it's like, okay, click here and you can edit that exact page. You think it's not marked down? That might be. I mean, this could be any number of things. Once you get into static site generators, there's lots of different options. So let's see. Okay, let's see. Sorry, I thought I had my kubeconfig set up, but I only have it on Windows, and if we look at the install, it's all bash scripts. So I'm going to need to figure that out. And I just don't want to show off all of my my certificate stuff. Oh, and I'm not sharing my screen. Even better. Okay. Okay, let's see. Let me go back and share my screen and okay. Let's see. Yeah, this is Windows. I have Windows subsystem for Linux, and I'm using Minikube on Windows. I like getting that experience of what's it like, and so this is the first hurdle I'd probably feel if I was a Windows developer is, oh look, here's a bunch of bash stuff, and I have to interop it. Nicely, if you haven't done it before, Minikube has some nice, okay, if you're using, Linux, do this. If you're using Mac, do this. If you're using Windows, do that. And then everything else goes basically the same. I understand it can be hard to get different, install instructions. And so these shell scripts are kind of handy. But, oh, that's not the way I wanted to view that. Let's see. And, oh, nobody else is going to be able to read this. Let's see. I do have VS Code. Let's see. Shoot. I just got into magnification mode. Give me just a moment here. I've never gotten magnification mode by accident before. There we go. Okay. So let's see. What does this actually do? It's pulling in the CLI. And parses a bunch of stuff. See. This is a lot of stuff to just sort of pull in and feed into Bash. Okay, let's see. I'm switching up the paths in my kube config, and I think at this point, I'm not going to have any secrets on here. So that's one annoying thing about kube config is it's not something you can go and edit live. Or at least not on a recording, unless you want to rotate all your keys. That doesn't really sound like my idea of a fun afternoon. And I screwed that up. Okay. There we go. Now we've got Pixie working. And that's Minikube. Here's our quick start install. Lots of different ways. I like seeing what I'm going to do. Oop. Well, that says Darwin, so I'm going to need to switch that. Spell it correctly. So this is interesting. They tell me to check that the signature matches, but they don't give me a signature to match it with. Actually, the challenge I've had in the past with Windows, in addition to WSL, is that in some cases you're not allowed to run a VM on your machine, and so you can't actually use WSL. Well, let's see. Here is our PX binary and manage API keys. Auth. Huh. Let's see. Update available. I just downloaded this. Which is it? And it said latest. Now that's a little alarming, but table ID demo list. Okay, I'm wondering what's going on here. We'll probably dig into that a little later. Demo deploy. Yes. Let's see what this does. So, let's see. Looks like we're creating a catalog and a RabbitMQ and a database. Okay, the carts database is running. The RabbitMQ is running. It looks like the catalog is still... okay, there's the catalog. Oh, that's the catalog DB. Catalog should be... Oh. More stuff's getting created. What do we have now? Okay, so we have a carts and a carts database, a catalog and a catalog database, a RabbitMQ, and a user something. And let's see. Looks like this is something Java. Oh, now we've got a session DB too. Well, while this is doing that, I'm wondering if we can find where the actual code is. So demos, sock shop. Well, here's all of the YAML that it's applying. But why does the YAML take so long to get there? And yeah, everything is... If we look at the carts, this is running Spring Framework. Let's see. Let's look at orders and see what that is. That's a JVM too. Yeah, this idea of having demos being a part of the CLI is a little weird to me, but let's see. Our package to allow px deploy. There's a manifest.json. Here's some instructions. What is this? That's a lot of Bazel. I mean, it's not a lot of Bazel, but it's enough Bazel to intimidate me a little. So here's the Pixie CLI, and they're using Logos, and they're not. It looks like they've built their own main. Ooh, analytics. I'm wondering if I'm reporting all of this already to. Okay, load testing has been launched. Let's see. Here's load test. It looks like it's still in init. It looks like most of the other stuff is running, but not all of it's ready. So let's see. Next thing we're going to do. Deployed it. Oh, now we're supposed to deploy Pixie. I do like it's doing a pre-flight. Yes. Oh. Okay, let's see. Google. Okay, so we can copy this. I am let's see. This did not work. Users not registered. Please sign up. That doesn't look quite right. I'm also wondering why this token at the end has a hyphen. That looks a little cut off. So if you remember why, how this works, there is, where are we? Back here. If you look at the, how it works, there's a portion that's on the cluster and there's a portion that can report to the cloud. And if you go back and look, at px.dev. There's a bug about self-hosted install script coming soon. And so currently there is a hosted thing, and the code used for hosting is open source, but it does try to hook you up to the cloud. And it says the self-hosted will have no external dependencies, but you'll have to manage it yourself. And it says, I want self-hosted Pixie now, and here's some stuff for doing it. You need to go through the sign-up flow. Okay. Well, I kind of want to see what this looks like, so let's see. PixieLabs.ai, sign up. Sign up with Google. Let's see. Signing me up. Install it. Okay. Looks like now I'm signed up, and maybe now I can try this again. And okay, now the auth is successful. Well, that's a little surprising. It would be nice if when I did this login, it would tell me, oh no, you need to sign up first, rather than giving me a token. Let's see. So now we need to do px deploy again. Cluster type, user can create namespaces. Cluster. So this is interesting. I'm guessing that this is because it's actually figuring out that I'm not using the KVM2 or HyperKit drivers. If you look at the self-hosted, they had planned to open source a mechanism that didn't go through the cloud, that you had to run yourself. And it looks like if you use this scaffold file, you can build one. That's a non-trivial scaffold file, so I'm not sure how quickly we can swing into action and set that up. But it looks like they're working on a completely self-hosted version. But yeah, the fact that you need a cloud connector is, I don't think that's the long-term plan, but right now, yeah. Let's see, what do we have now? Whoa. Oh, that's interesting. Wow. Okay, create container configure. This may be a short. Error while dialing container D. That's interesting. And why did this crash? Let's see. Container. Back off restarting failed container. Let's see. Killed. Got a signal 57. Interesting. I wonder why that happened, because we were passing readiness checks somewhere up here on these databases, and now they are not. create container configure. You think it was an let's see. Oops. Why is it not finding minikube? Timed out waiting for cluster ID assignment. That's not totally surprising given that everything seems unhappy. So our requests and our limits are well under, but yeah, whoever was guessing system was correct. This is with 8 gigs of memory and limits nowhere close. Oh, but I'm noticing that all of this Pixie stuff is making 0 requests. Which might not be great. Let's see. Let's see. See if I can make this bigger. Yeah, well, let's see. We've got a lot of stuff in buffers and cache right now, but also a lot of stuff crashing. Let's see. We were looking at this Visitor proxy, and it failed to create pod sandbox. Error while dialing. Let's see. Control-L. Let's see. Why is this? That's not very useful. Been a while since I've had to debug inside. Since I've had to debug inside Minikube, so it may take a moment. And that huge Java app deployment. Well, so this is in an 8 gig VM. So this is a Linux VM with 8 gigs of RAM, which is in the quick start, somewhere over here. They suggest you can do it with 6 gigs, and I added a little bit more to be sure, but does not seem to be true. I would definitely believe that. Let's see. Wait. So this is an Envoy proxy. Let's see. PL NATS1 is in error. That's one. What is this trying to hit? PL NATS management. I don't see a PL NATS management. Oh, I can't have the demo running at the same time. Okay, well, let's see if we can clean this up then. Yeah, and as I was saying, we've got 8 gigs. Okay. Maybe I should spin up a new Minikube. Give me a moment. Let's see. Can I update a cluster, or do I have to delete and recreate? I have to delete and recreate. Okay. Oh, is there a simple demo? I've got 32 gigs of RAM, so I could spin up a new Minikube, or I could do a smaller demo. Let's see. If someone wants to point me to a simple demo, I'm happy to do that. Otherwise, we will get a new Minikube. Let's see. Pause. What this? Okay. Let's see. Minikube start. Pixie 2, CPU 6. Memory. Okay. Go Minikube. Yeah, so while this is kicking off and pulling the image and all of that stuff, I thought maybe I would go back and look at the demo stuff and see how it was doing that. There's cloud depths. So let's see. Analytics client, cmd.execute. Here we go. So this is using Viper. Add commands. Here's the demo command. Let's see. Oh, a cluster. I could spawn a GKE cluster too. But usually Minikube doesn't take too long. Here we go. So let's see. Okay. Okay. Right. And give me just a moment to clean up my file paths. one more place. Okay, let's see. Gonna want that too. Whoops. Okay, let's see. That should do it. Okay, now let's try px deploy first. Online boutique is smaller. Let's try that. Yes. Let's see. Well, we've got 18 gigs now, so we should be fine. So yeah, now we've got plenty of memory. I don't know why it's saying it's got 16 CPUs, but yeah, now we should be able to do px now. Deploy px workshop. Okay, I'll use the online boutique. We should have plenty of space then. Let's see. Okay, it looks like we've got stuff going. Well, it may just be that you want to change the simple demo app to prefer the smaller one, with a note that there's a bigger one and that you may need more cluster resources to do it. Oh, and they've got the list of built-in scripts too. Interesting. Let's see. So this PM is still running and Kelvin is still doing it to knit. Everything else seems okay. It looks like the online boutique is everything except the load generator is running. External IP is pending. Oh, it needs a Minikube tunnel. Okay. Cube tunnel. Okay. Let's see. There we go. And now everything's running. Great. So I guess next we... I don't see as many databases here. So we have a lot of different services, but almost no backing databases that might be taking up a bunch of space. So let's see. Here we go. PX scripts list. Oh wow, there's a whole bunch of these. Let's try this one. PX run Agent status. Okay, so this tells us what agents and stuff we've got. PX pods. Oh, I would need to pass a namespace in here. Space. How am I supposed to do this? PX run script. Well, I guess I'll figure out how PX run works for other stuff later, but let's try the demo script. Okay, so it looks like this is, as they described, proxying through the cloud to the Pixie API. One of the things that we can do in a little while, a quick start. So there's the web app, but we can configure the data transfer mode. So the default is to pass through where it goes through the cloud and access data without being in the same VPC and network. And so when we look at this here, somewhere it says it will be in a pass-through mode. Over here. So cluster, Pixie 2. Here are my namespaces. I don't actually see something that looks like the page that they're talking about here. But it looks like the URL should be /admin. So let's see. Okay. So here's the other one, and I can see that it is in pass-through mode. If I want to be in data isolation mode, I can switch this, and we go directly to the module in your cluster. So let's see. We want to do this. Oh, that's interesting. So this is actually talking to the cloud service when I run px get visitors, not to my Kubernetes cluster. Because otherwise it wouldn't know anything about this other cluster that only got halfway set up. And then see this pass through equals false. And now let's see. If I go and look at this, let's see. This is now going to try to connect to my cluster, and it's probably just going to spin because I don't have pass-through mode, and I would need to get the network set up there. And let's see. And this should say, if I go back to admin somewhere. Here we go. The mode is direct. And it looks like I can't change it in this UI, but I can go back here and I can set pass through equals true, and we'll be able to see it again without needing to set up a load balancer and stuff like that. So this is your browser. So actually, let's go back and switch it back to pass through false. And then what we can do is, oh, that's nice. It updated really fast. So we'll look at our cluster, and then we will open our handy developer tools. I just updated you, Chrome. Why are you asking again? And whoa, okay, stop. So we're making these GraphQL queries. Let's try reloading the page. Clear. Start recording. Reload the page. Stop recording. And filter. Pixie start time. So this is all going to with Pixie.ai. Somewhere in here, here we go. Oh no, that's Lunch Darkly. Health check. So now this is trying to hit this URL, this 192.168 URL, and I bet that if we look over here and we do kube control get svc -lpl, no, these are all 10-space addresses. But this looks like this is the address that it's trying to pick up. I'm not sure where it's getting that. My guess is that you're seeing all the crazy GraphQL both because they're trying to do stuff live and update the page, and because everything is busted right now. So let's see. This looks like this is trying to go through some address that, let's see, might be associated with Minikube. Let's see. Cube IP. Oh, hey, look. Here's my Minikube IP. And over here, they're trying to hit that Minikube IP. And so I would need to set up forwarding on all of that to make it work. And so it's nice that they can proxy you through the cloud and do sort of a reverse pattern. It looks like it's also possible to set up locally, since I'm interested in figuring out everything else. That was quick. I don't know if you noticed that. I switched it back. And all of a sudden it popped up, and I have a Pixie 2 node, and I can look at my CPU usage. Seems really high. Oh, but I bet I have a load test running. Let's see. Let's see if we get our pods. Yeah, we have a load generator running. So it's not totally surprising that our CPU usage is kind of high. Let's see. Received network traffic, resident set size, virtual memory size. So we can group things by node. We can group things by namespace. So we can see that almost all of our CPU load is coming from PX Online Boutique, but we are spending, I guess, about 20% of our CPU keeping track of all of the work going on. Bytes read, bytes written, virtual memory size. And if you remember back here, this stuff is actually getting proxied through the cloud to the Vizier on the cluster. So all this data isn't actually getting pushed up into the cloud. It's the 3D connected visualization of things. That's probably a different... Ooh. Oh, that's interesting. I can select a whole bunch of different scripts. So let's see. HTTP request stats per flame graph. JVM stats. Let's give that a try. JVM. Ha! Okay, so we can get young GC times and used heap size. And it looks like this is doing it by pod, and there's one pod that's using a JVM. Let's see. Pod memory usage. Well, this gives me current memory usage of all these different things. Let's see. Looks like I can't easily, in this one, filter namespaces. But let's see. Here is a scratch pad. So you can write your own scripts here. Well, let's see. Let's go back and we don't need requirements anymore. Let's see, quick start. So we deploy Pixie, we run a script. Look at our live UI guide. Is this... That is loading. Yeah, the short form is, I think all of this is actually being transformed. So select your cluster, run the script using the run button. Running the script, you should see, oh, which one is this? PX cluster. Looks like cluster is the one that you wanted to see. Oh, and this actually shows us the query too. But it's not showing the service graph you wanted. But it looks like you have Python scripts that let you actually visualize all of this. I'm not sure. Let's see if we... Looks like you can cluster things by service or not. Let's see. If we look at PX Online Boutique, we get a list of pods. I'm not sure why we're not getting... why we're not getting any content in here. Service graph. Start time is 5 minutes ago. Oh, interesting. So if I can say it's 10 minutes, inspect the page for errors. Let's see. Developer tools. Yeah, not network anymore. Console. Infinite extent for field type. Well, these are all warnings. Failed to load resource. Oh, but this might be a while. Is that Pixie audio hijack? I don't think so. Let's see. I'm back now. Great. Okay. Great. I have no idea what happened there. Technology is a mystery. For now, I'm wondering why this PX cluster doesn't render a service graph. But so yeah, it looks like you can write your own scripts to do your own representation. This is a little bit like Grafana, but it looks like it is, according to the chat, it's a Python-like language, so it's not actually Python. But you can, in here, if you do go in and edit this, it looks like there is a way to add an argument, I think I saw. So that's not what I need. So next to these parts here, you can add more scripts. And let's see, if I look for start time, these all take start time, and some of these take extra arguments like entity. Nodes for cluster. Let's see, is this the one that I need? So these all take a start time. And, over here in variables. So if I do something like this, name, let's type px string, description, just testing, default value 10. And then I guess I need to hit run again. Oh, nope, when I ran it, it removed that. Follows pandas. It's a subset of Python. So it's nice. It's nice that it's a subset of Python so people can reuse that rather than sort of having to learn their own language. So that's kind of nice. And let's see. If we look at, I thought I saw that there was px service. Oh, and we need to pick a service. Checkout service. Payment service. Okay. So here's the demo script. Let's run it. Oh, this is kind of interesting. So we can actually see individual HTTP requests. You'd want to be careful with giving this out because you could have PII in here. I'm wondering if there's some way to scrub certain parts of it so that it looks like maybe we only get request path in here, so that's actually not too bad, assuming it doesn't have like a token or something like that. Oh, that's cute. So this is a script that actually tells you all the functions that you can use. Yeah, it looks like this was an existing New Relic service and that they are they're open sourcing it. So I thought that was pretty neat. So this is interesting. So this is actually giving us an overview into all the DNS queries going on in our cluster. So we can see we're looking up this name and we're getting back the answer. And so presumably if we wanted to, we're getting stuff from DNS events and df equals df dot. I don't remember. It's been a long time since I used pandas. How do I filter down to specific rows? Because I should be able to take this raw DNS data and then actually go in and, for example, limit it to one namespace. Or look at only things that take more than a certain amount of time. But let's see. We copy this. That's queries, request body queries 0 name. I want to be able to do something here. And then well, I think this is a different model. This is more of a data processing model, Carlos, than a like a query language. You can think of Grafana as more of a more of like a SQL standing query. And I think you could if we turn this, if we go to the visualization spec and we set some variables in here, you could actually do, extend this so that it would do that. So if we said name is namespace. I don't remember what the other stuff was. Python should allow it to modify the HTML. I'm not sure I follow. Editing script arguments. Is there more documentation on this? Not here. To write your own. Here we go. Writing pixel scripts. Oh, set up the script environment. Let's see. Data frame, display, inspecting the output. PX schemas, end time, drop columns, keep to return of data frame with only the specified columns, select. Ooh. So over here, if you notice, this DNS stuff right now has a bunch of stuff in it, including the request body. But I wonder if we can actually say select equals array of things. Rec body queries. We have to comment this out because that's not real code yet. And then, oh, they didn't like that. Rec body.queries, I can't see that. Okay, so this would give us just the queries. I don't know enough pandas to be able to filter. Oh. df.role equals 1. Huh. Can limit the rows returned, but that doesn't tell me how to get into the inner data. Bringing in pandas does feel pretty cool. It does. It is kind of like a Jupyter notebook. Um, you can edit this stuff, and then if we take out this select, oh, we can still do this head. And now let's see. If we say max num records is 5 and we hit enter, then we just get 5 queries back. And it looks like maybe I might be able to say df dot query equals df dot recbody dot query 0 request body. I've done column is not subscriptable. So now I end up with 2 of these that are repeated. I don't know how to take apart the JSON from host and inside the pod. Oh, I'm pretty sure that it's recording the DNS queries. I was hoping to be able to filter things to only this online boutique or only like Cube system. And I don't know how to take apart I don't know how to take apart the JSON. Ooh, this is cool. So it's got this contextual information. We can also do a group by and build aggregates out of that. How to do some filtering. Yeah. Well, if only I knew how to... One of these days I'll remember my Python. Let's see. Oh. You think that's gonna work? Yeah, so this is a subset of Python. It's not actually Python. It's Python compatible pandas looking stuff, and so I need to call this px.display to show things, but I might be able to say px.display df.recbody arg out as type operator received column. Let's see, somewhere in here let's see, keep this just in case. And then they had a functions. Do they have table functions? Here we go. Get tables, get trace points. Abs. A bunch of equals. Do not see the string JSON, which is what I was hoping for. Pod ID to namespace. That's kind of cool. Well, this looks like something where I would have to, yeah. Yeah, pandas, to go back to the HTTP data query, for example. Pandas does some interesting things, and over here in the tutorial, you can see that pandas is overriding the not equals operator on this service column to actually do a filter. And I'm guessing that the indexing operator is also overridden. So it's Python, kind of. And you can pass in a Python function to evaluate on each field, but it's really kind of its own thing. So let's see. Oh, and you can see here, this method, someone was wanting to add additional arguments. This has both a start and a max num records. And you can see that start and it's called num head over here. It's called max num records over here. But you can see down here there's a global funcs. Oh, that's interesting. So you also define some global functions and you do a mapping between the variables and the arguments. When you've got stuff like this, there always ends up being these extra intermediate layers. Are you still hearing me? Now I'm paranoid that my microphone's going to misbehave again. So let's see. Yeah, so you can write your own. It looks like you may also, if we go back, underwater robot voice. Uh-oh. Is this better? This is me having messed with my OBS setup this morning, like a fool. And okay, so this is all live stuff, but I think you can also BPF trace deployment. They also have some other examples of being able to do things like instead of adding logs here, you can actually insert dynamic traces and say, hey, log every time that this happens, and it goes in and dynamically instruments the cluster for that. And so I'm not going to run through all of that because it looks like there's going to be a whole bunch of setup to do. But yeah, this is a pretty neat capability to actually add debug logs or script of the week, flow graph. Yeah. So they have some other things like that, like database query profiling. That Colab notebook isn't there anymore. Let's see. Yeah, I don't know where that Colab notebook went. Someone will have to dig it back out. But it looks like you can pick out individual slow queries. Do request. Okay. So, for those of you who weren't aware, Pixie is pretty new, and I think we're seeing that in some of this documentation. Monitor the health of your services. And this also points to a Colab notebook that's no longer there. Scripts. These don't look like the scripts that we want. Source pixel scripts. Script of the week. But the nice thing about having this in a language is that you can also like check these things in and share them around. So I really like that you can get these. You can see the arguments get reflected up here as links. One thing that I would suggest adding is the ability to set the end time, which is really handy if you do have long-term retained data, to be able to say, during this outage, link, we did this, and people can go in and look at the actual data and, you know, go back and see if there would be a better way to detect the problem. And then I like that it's using, you know, pandas rather than like, oh, we made up yet another language for you to learn. But yeah, I think I'm about the end of what I can explore right now. I'm glad that we got things working. You know, it only takes 16 gigs of RAM. Actually, I suspect we don't need anything like that now. Let's see. If we do a minikube SSH, oops. Let me try the right VM. Yeah, so it looks like this demo is actually only, because we picked the smaller demo, we're only using like 4 gigs of memory. And, you know, I'd want a little extra space, but the other one I'm guessing is a lot bigger. So Pixie and Prometheus seem like they're slightly different things. So Prometheus, let's see. So Prometheus is basically a metrics aggregation system. So you need to instrument your code ahead of time to collect all of these metrics. And then Prometheus does a great job of storing them historically and letting you know, okay, 6 months ago or a year ago, you know, my data looked like this, and now it looks like this. Whereas Pixie seems like it's a little bit more of a debugging and app instrumentation system, which isn't surprising given the folks at New Relic have been doing that for many years. And so it looks like it's a lot easier to dig into individual data points, and I'd actually be really curious what the underlying data structures they're using are. It looks like it's more likely to be sampled traces than aggregated metrics. So Prometheus's model of the world is basically things happen and you increment counters, and your counter, you know, goes up over time, or maybe it's how much disk space you're using. And so you get a number for that. And then it does a bunch of collection on numbers and lets you group them up by labels and do math with that. But it's basically a time series of numbers. And it looks like Pixie is closer to, like, you know, to here's a bunch of database records that's a sample of everything that happened. And then, oh, Carlos, let me let me show you that in just a moment. So it's running on the machine, and it's actually instrumenting with the kernel and instrumenting with the processes, and knows what's going on and is taking traces and is storing them off to the side. So let's see. Supported protocols. I don't know if you saw this, Carlos. If you're using one of these libraries, Pixie can trace the traffic, and my guess is that how that works is that they recognize the library entry points. And so every time you call like SSL encrypt or you create a connection and you call read or write on the connection, they can actually hook that. Oh, nobody can see what I'm seeing. They can actually hook these read and write calls in the library. And so they can actually collect what you're sending over the TCP links because they've... if you hook the Go TLS and you replace all of the methods on connection with thunks that record what you're doing, and then you can pick up the net connection and you can pick up the reads and writes, and you can actually trace over TLS, which is really clever. And yeah, it could probably intercept the mutual TLS for Istio. If you're using Istio, Istio can also actually has instrumentation that can do the same thing. They've added that instrumentation into Envoy manually, but the clever thing that Pixie is doing is that they're actually automatically doing it. They're also using eBPF. They're basically creating a whole bunch of different trace points in different parts of the program. And so there's some trace points that are going through the kernel, and there may be some trace points that are in the application itself. And you can, put a whole bunch of different trace points in there, record those traces, and then see, okay, these things happened, and then they happened in the same thread, so I'm pretty sure that, that it's all part of the same thing. The really interesting thing is for Golang, eBPF on its own may not be sufficient because Golang uses green threads. Oh, eBPF can do trace points in user space. I didn't know that. Cool. Okay. So yeah, they're probably using eBPF for that. They are probably also having to hook the Go thread implementation because all of your Go processes, or your Go functions, your Go routines. That's the word I'm looking for. All your Go routines are multiplexed onto Go max procs. So onto like 4 or 16 threads or something like that. And so they actually have to keep track of the context switches that Go is doing in user space. And it looks like there are some directions on how to get started. They have some development instructions on how to get everything set up. Haven't tried doing this yet. But yeah, this is a really clever set of stuff. And it looks like they are looking to collect a lot of different data. And so, yeah, this is exciting. And I'm excited to see that it's coming out as open source. For those of you who aren't familiar with it, Google has a stack driver debug technology that is a bit similar, but it's all in their closed source system. And it works not quite the same because it actually integrates as a library. So it's pulling things out from your application binary rather than pulling it out from the kernel side. But yeah, we should be able to get trace details of, let's see, do we have Go? We don't have anything Go in here. HTTP data filtered. It looks like maybe they are excluding the Kube system namespace in their data collection right now. Because I see a bunch of services, but I don't see the Kubernetes service, and I would expect that it was there. Let's see. Describe. Let's go back to how it works. These are the Pixie edge modules are the things we want. So here we go. We've got one of these. Oh, that should be N, not O. So this is our daemon set that runs on every node. Our command is a shell command, waiting for the URL. Oh, that's an init container. Never mind. That's not the interesting one. So we've got some environments, JOT signing key, host IP, mount cert from host root, a service account and assist, and it looks like this is only mounting stuff. Looks like this is not mounting anything directly that tells it what to look at. So it's probably getting directions from Vizier. So see, I'll get okay. PL cluster config looks interesting. Custom annotations, custom labels, disable auto update, etcd, etcd operator doesn't look like there's a lot there. This may be hard coded. I'm going to let someone else dig in and figure out how to actually get it to trace Kubernetes stuff, but it looks like it probably should be able to. What is this Kelvin thing? Kelvin's not mentioned there. Host path, pod name, namespace. I don't know what this thing is. That's curl, and this is Pixie prod, Vizier, Kelvin image. If we go over here. It's a thing. It does stuff. I don't think I'm going to get to the bottom of it in the next 5 minutes, so I think this is probably going to be where I cap it off. But yeah, Something to keep an eye on. I'm particularly looking forward to, and I'm probably going to watch this issue here for self-hosted Pixie install script, because I'd really like to run this on my own environment without tethering it to a cloud. So even if it's a bit of extra work, I like that for just learning how stuff works. So hope you all are having a lovely lovely day and a good evening or afternoon or whatever you've got. It's sunny out here still, so I'm going to get a little more of that sunshine.